Tell me your name and tell me a little bit about your project.
My name is Sir Arthur Eddington, and my whole point behind this experiment is putting Albert Einstein's general theory of relativity to the test for the first time during the total solar eclipse, and it's the year 1919 right now.
Alright, so what are you guys trying to find in this project?
The whole point of this project is trying to measure how much a light ray would bend when passing through a large object such as a star. Isaac Newton already had a theory of light bending in about 200 years ago in 1704. He had also calculated and predicted a value for the light rays bending backwards on background stars when grazing the surface of the sun. The predicted value of the shift was approximately less than a second. It was 0.87 seconds of arc. The theory of general relativity also stated that light ray would bend, but the bend was twice as big as Newton's theory at approximately 1.74 arc seconds.
Alright, so where did you conduct the experiment?
This experiment was done on the island of Principe. It was off the African west coast. We also sent a group of astronomers to Sabro, Brazil, in case clouds blocked the eclipse.
Alright, what else was going on during this period?
During this time, there was a lot of major world activities going on. Newton's law of universal gravity was still the most widely accepted theory. Also, during this time, World War I was coming to an end. The Treaty of Versailles was signed on June 28, 1919. The theory also stated the space and time were relative, forming a four-dimensional continuum. All this was done within the same time span around the year 1919.
Alright, who else was involved in the project?
In this project, we had various people involved, but one of the major key components was Sir Franklin Dyson. He was the brain behind the experiment. He's the one that put it together. He's the one that designed the experiment because the total solar eclipse would happen right as the sun was crossing the Hyades star cluster. The light rays would have to pass through the sun's gravitational field because it would occur during the eclipse, causing it to be dark. And Dyson realized this would give the ability to have an accurate measurement of the shift that gravity would cause.
Alright, and what exactly was your role in the project?
My role in this project was to be the leader of the experiment. During the months of February and January, I had to measure true positions of the stars and see where they're at and location exactly. And around in May, I measured the position of the stars during the eclipse. After taking several pictures during the eclipse and having astronomers in Brazil take pictures, I have returned to England and I started reviewing the different information and data that we have collected. It confirmed Einstein's theory, and later on in November, I published my work.
So what impact did your project have on the physics community?
The biggest impact that this project had on the physics community was that the idea that light bends when passing a large object known as gravitational lensing. It's used widely in astrophysics. It can help and had helped physicists understand the expansion of the universe and the dark matter behind it.
And how did the scientific community react to the results of the experiment?
There was different reactions. Some people were for and some people were against it. Some of the scientists in the community were skeptical of the results. They weren't sure how to go with it since I was going against Sir Einstein's theories. The reliability of that data was a large concern as well. The conditions during the experiment were not the best. In Principe, it rained heavily. The weather was not the best. Especially rained heavily on the day of the eclipse. though the clouds mostly cleared in time for the eclipse to happen. Meanwhile, in Brazil, the team used a smaller telescope that warped the larger one regarding the weather, and it helped us collect better data and so on. And this experiment was repeated later on in 1922, 1953, and 1973, with all the results being very similar. And by the 1960s, Einstein's prediction of how much light would be deflected was the most widely accepted correct answer.
All right. Thank you for the interview, sir.
Thank you.